Ready? There should be nothing there. That's exactly what I want right now. I realize that's confusing. Okay. Perfect. Right, good afternoon. Almost. Hello. Actually, that's going to give me a big loud hello. Hello. It's not bad. It's not bad. I did that in a couple of countries back, and so I said, give me a big hello, and they went, To be fair, it's the end, coming towards the end of the conference, although it's not really, because PubConf is coming. If you're not going to PubConf, unless you've got a fantastic reason not to go, unfortunately I have one, I've got a daughter, I've got to go and pick her up. But unless you've got a fantastic reason not to go, you should be going. It's the most entertaining highlight of the year, frankly. Okay, so who has seen me do talks before? Excellent. I can completely reinvent myself. Okay, so you don't know how bad I am with the guitar. That's a good start. If you don't, you probably wouldn't have come in. Okay, so what I'm going to do, I'm going to start off with my talk with a bit of a song. Hopefully, something that you relate to. Don't worry, I don't sing. But the song hopefully explains some of the context to what I'm going to talk about in the rest of the talk. So let's get going. And now to the serious stuff. Okay, so hopefully from that little ditty, you've got a slightly different view of something that we all rely upon, which is production. You see, I've heard a few people in the industry say that production is the place where things work. In my experience, production is the place where things don't work. In fact, I think production hates me with a passion. Oh no, it's not distributed. It's not like it doesn't know who I am. It knows who I am. It knows when I want to be asleep. It knows when I want to go on a romantic evening out. Really knows those. It knows how to destroy my life, and it's not afraid to try. So let's switch over to a few slides. Don't have many. Okay. So before we get into the depths of what production is like, let me start with a quick introduction of myself. Like I said, I can completely reinvent myself since you've never seen me before, which is fantastic. First of all, I'm on Twitter. I live on social media. I'm unapologetic about it. I really rarely read emails, so please don't send me one. At any moment in time, I have 90,000 unread emails in my inbox. I'm purposefully stress testing Google. But if anyone sends me an email, please don't, because it ends up being one of them. I treat email like Twitter. It moves past as a continuous stream of something. Okay. I'm also a dad, so I do have a responsible side. And yes, we are those irritating people that get into Christmas way too early. This was actually roughly, I think, August or September last year. We were out Christmas shopping, which was fabulous fun because, frankly, we got so many horrible looks from people. It's great. As well as that, I've been writing some books, and I do courses on chaos engineering, which is what today is all about. As well as that, though, I have to tell you something else before we get in, because it's actually related quite closely to my attitude to this subject. And that is, I clearly believe I'm a rock star, and I'm not one, but I'm also a biker. A very serious bike. Well, as serious as you can with what is essentially a sofa connected to some wheels. And as a bike, anyone here a biker? Anyone got motorcycles? Right, fantastic. Now, when you're learning to ride a motorcycle, as I was only a couple of years ago, that was my first bike, by the way. I went from a 125 on the weekend to the following Friday on 1,600 cc's of heavy beast that wants to kill me. Fantastic fun. Now, as a motorcyclist, when you're learning to ride a bike, you're not taught the way that car drivers are taught to drive cars. Generally, when who's got cars? Actually, in London, this can be tricky. Hey, excellent. There's a decent amount of you that have cars, which is rare for London. It's good. When you're learning to drive a car, you probably get told, or it depends what country you've learned in, of course, you probably get told that you have to drive like no one else can see you. Right? You drive defensively. Well, on a motorcycle, we're not told that. We're told that everyone can see us and wants us dead. The road is a hostile environment populated purely by psychopaths. And that's how we get by. That's how we live a little longer and enjoy it whilst we're living. This is relevant to the subject at hand because that's what I want you to be like when you deliver your software to production. And I'm going to explain to you how chaos engineering helps you think like a motorcyclist when you deploy and run your code. Before we get there, I just have to plug very quickly the fact that there's now an announcement. I'm actually doing a tour across the US. This gives you an idea how crazy I am. I'm doing a tour in April across the US. Most of it. On a motorbike. Doing a talk like this every night. For 26 days. So either I'm going to be very good at giving talks by the end of it, or I'll be dead. Just to let you know how bad this looks, this is the first half. You know you're doing a long tour when Google cannot handle the whole route. I think it's about 11 waypoints, and it says, stop it. You're not doing it. So this was the first chunk of the journey. I end up in Dallas, which I'm fabulously happy about. And then the second half. And I end up in Chicago, which is where the conference is. So everywhere I stop, I'm doing talks. So if anyone comes from any of these vicinities across April, give me a ping. I might ride to you. and have a conversation about chaos, which you're now going to find out about. So, does this make me utterly insane? Should you not really be listening to me? Possibly. But at the same time, I don't really think of myself as insane. I tend to think of myself as an agent of chaos. See, I'm constantly stressing my life, and I do the same thing to production. I stress it in ways where life can be better and more interesting. Admittedly, I've had 2 divorces now. That's not the best stressor. I can't recommend it. But that is an example of the fact I do stress things as I go, and that's how I want you to think about your production experience. You see, there's a fallacy out there. People tend to believe this is what production looks like. Serene, beautiful, polished. You ever see those photos of the operations center, the data center, where it's all like blue lights and calm? I should actually point out, this is not far from my house, and this is actually the south coast of England. And the beautiful thing about this picture is if you were to look there, there is the UK's biggest suicide spot, which I think is quite related to production. It's actually Beachy Head, just over there. But yeah, serene and beautiful, that's what we think production might be. And whenever I hear that, my reaction is usually along these lines. I mean, I had this conversation recently where I was sitting with a relatively new group of developers, and they said, yeah, in production, everything, it always works in production. We have to build big pipelines of checking and gates before it gets to production, because then it'll work when it gets there. And I watched the senior architect in the room, and his body language was beautiful. It was, and he just muttered in that way that age-old pain has on a tone of voice. He muttered, "No, it doesn't." And they all got a life lesson right there on how production doesn't want your stuff to run. Because rather than it being this, I think it tends to look a lot more like that. Where really, rather than perhaps putting fuel on the fire, people are desperately trying to put the fires out. And then desperately trying to figure out where the next piece of kindling is going to be lit. Okay, so the first thing you need to know about chaos engineering, which is often done in production, is it has nothing to do with chaos. We, as an industry, should stop naming things. We're not good at it. I mean, don't get me started on NoSQL. Who decided to define something by what it's not? And then get it wrong, it's actually something that it can have. You know, taking a beautiful renaissance in data access and persistence technologies, and we call it by what it may not have. And it wasn't even the problem in the first place. Okay, so chaos engineering has nothing to do with chaos. That's the first rule. What it has to do with, what it's trying to help us deal with, is a natural occurrence in our systems. So I'm not going to ask you who's using Kubernetes, who's down with the cool kids, who's got Pivotal Cloud Foundry because they've got a lot of money, or any of those things. What I'm going to ask or point out to you is if you're doing anything like what you could potentially call microservices, you are creating a wonderful problem for yourselves. Don't get me wrong, as long as you're doing microservices for the right reasons, like you want to evolve your system quickly and organize your people around the code effectively, fine. However, there's a cost. And the cost looks like this. When we look at Kinevin, this is the Kinevin diagram, and I'm going to sort of abuse it a bit today. We tend to think we're about there with our systems. Unless you're, I mean, down here, it's Hello World. All right? Unless you, I mean, if anyone here is professionally paid to write Hello World programs, well done. Respect. But generally speaking, we think and we believe we're up there in complicated land where there's good practices, but we might not be aware of them yet. They're good practices. That's why we come to conferences, to find those good practices that we can apply, and we can just apply them to the system. And it will probably make things better. Probably. If you're doing microservices or anything we're starting to call under the umbrella of being cloud native, then you're probably in complex land. You're not in complicated anymore. You're in a world where really there are no great and good practices. There are ideas. There are things you could try because it's all quite unique and different and painful to look after, but you've hopefully done it for the right reasons. And so you paid for that ability to evolve the system with complexity. Then comes the nasty awakening moment. If you're building cloud-native microservices, and they should be able to evolve quickly, that was the point, a system that can change as quickly as the business changes its mind, you've got constant change on your system, and that shifts you. Periodically, every now and then, you're shifted into the chaotic, which is where chaos gets its name from. It's a recognition that the system is complicated, complex, and then at times chaotic enough that the only way of dealing with it, you can't formally define it. You can't sit back and go, it's perfect. It now works. If you've got a perfect system, there's 100%, no, it doesn't exist, 99 point whatever many nines you want to add to it, uptime. If you've got that, it can never change. That's what site reliability engineering starts with, is if you've got a system that's going to change, accept the fact that there will be failure. So we want change. That's what we were trying to buy with doing these complicated systems. But now we've got this issue of anyone responsible for saying it's all working is in a difficult place. They don't really have a tool for that. Didn't really have a philosophy for it, even not that long ago. So what we're going to look at today is how we deal with this system. You see, this is where chaos engineering comes to the fore. It's about taking this happening and trying to drive us back into the system just being complex. Okay, let's have a look. Specifically, chaos engineering is about one thing. It's about availability. You're trying to look at your system from the perspective of a user and see what parts of it are available given a certain set of conditions. And then you, as a chaos engineer, you're looking to cause those conditions that potentially challenge your availability, ideally before they happen. Sometimes after they've happened. There's value in recreating those problems. Okay, so it's about availability. Availability gets destroyed at lots of different levels. Everyone's kind of familiar with Chaos Monkey, I suppose, and Chaos Kong and those sorts of things that tend to hit it down here and beat it up. We'll talk about why that's a great thing in a bit. You probably haven't done as much or experienced as many things that are doing it at the platform level, maybe killing Kubernetes pods or something. Application level, there's interesting stuff you can do to your applications where you've assumed that things will work. And the best place, in my opinion, to start doing chaos engineering is the biggest cause of system failure. You. I mean everyone. All people. What we do. Developers are system destroyers. We have the best of intentions. So what we do at the top level is a great technique in chaos engineering called game days, where you get a bunch of people together and you try to stress the whole system, what I call the socio-technical system of software delivery. You're taking all aspects of it and going, when this happens, because it probably can, or it has, what do we do? What do this group of people do to handle this? It's kind of like disaster recovery, okay? But it's kind of a practiced disaster recovery, a repeatable disaster recovery, something you do more frequently. So who here does disaster recovery executions at work? Everyone does it, say, once a year. Keep your hand up. Do it once a month? Keep your hand up. Yeah. My hands have gone down, right? So now, here's the skinny on chaos engineering. I mentioned the title's terrible. Now, you should never say to your managers, bosses, stakeholders, anybody, that you want to do chaos on production. You will not get a good answer. I had this conversation with a bank. They said, we're interested in what you're doing, Russ. What is it all about? And I said, well, we're going to do chaos in production. They said, no. No, we had 2008. We know what that looks like. They were very much, no chaos, no. Why would you want chaos? That's the thing you don't want. There are other nasty phrases you could use. We were going to break things on purpose. No, you're not. That happens accidentally enough, thanks. But I found a phrase that worked. I'm going to give it to you today. It's something you can take back and say, if you get interested in chaos engineering, this is the thing you can use. You can say, we're going to do limited scope, continuous disaster recovery. That works. First of all, disaster recovery is in there. Banks go, we kind of do that already sometimes. Then you say limited scope, continuous, because we're going to build confidence in our system. Who wouldn't want that? You turn around and say, I'm going to cause chaos, not quite the same reaction. So that's what, again, limited scope, continuous disaster recovery is the technique I've found works. Okay, and we do it over all of those levels because all of those levels can attack availability. So you've got a rapidly evolving system and you want to gain confidence in your availability. Chaos engineering is for you. So how do you do chaos engineering? A lot of this is straight out of the free book. There'll be a link to the free book at the end. You must go grab it. It's a free book. Why not read it? The first thing you do is there's a bit of a debate in the industry at the moment about whether it's chaos testing or chaos experimentation. I prefer experimentation, even though really we're not very scientific about it. Actually, I think as an industry, we're not very scientific. I mean, most of us have studied perhaps computer science, as it was called back at university. Who actually does science? Well, I play with computers a lot, but I don't remember ever doing a double-blind formal experiment. Not on my Mac, anyway. So, yeah, this is actually, though, an experimental procedure, a scientific method. You start off with a hypothesis, or in fact, what you do is you start off like most scientists. You poke things in interesting ways and go, oh, that happened. That's not supposed to happen. So you start off with that. You either start off with a method where you're actually poking stuff, or you start off with a hypothesis. And the hypothesis can go along the lines of this. I believe if service X dies in a fun and interesting way, like it exhausts its memory, then the system will survive. And the availability will look like this, as far as our users or whoever your consumers of the system are. Okay, so there's your hypothesis. I believe this will happen. If you start your experimental hypothesis with, I believe this service will die and it will take the whole system down, you're missing the point. If you know it will destroy the system, don't do it. It sounds kind of obvious like that, but it's really obvious. In fact, chaos engineering is not about destroying the system knowing it's going to kill it. If you already know, you don't do the experiment, you improve the system. You've already learned the lesson. Okay, you might still do the experiment to see what interesting ways it does die if you don't know that, but still, you probably don't want to be just knowing it's going to die and running chaos experiments. I actually have that a lot. The reason I put that in the talk is because I do a lot of chaos consultancy these days. Please don't damn me for it. I also build software. But the calls I get sometimes start like this, and I'd hate for your call with me, if it ever happened, to start this way. The call usually goes, we've been running Chaos Monkey in production. It destroyed everything. I'm like, yeah, that's what it does. Yeah, but we didn't think it would destroy everything. Well, so you missed the limited scope part of the statement, I think. So once we've got a hypothesis, one of the things where I tend to focus on next, which helps the business understand this technique in the first place, is I tend to limit the blast radius. I talk very early on about when we're trying to do chaos engineering, we say, well, what's the smallest thing we could do to learn something about the system? You know, you could go and run Chaos Kong, which, if you're not familiar with it, destroys regions of Amazon. Well, actually, no, it doesn't. It pretends they're gone. You can't destroy regions of Amazon unless you're Amazon or a hurricane, mainly because they've got other customers. So what Chaos Kong does is it pretends that, you know, the apocalypse has happened. With blast radius, you probably don't start with Chaos Kong. You start with, okay, what happens if the routing here goes a bit wacky? What happens to our system? It should be all right. It should be self-healing. Let's see. Or what happens if that service goes down? What happens to the user when this occurs? So you're exploring very small things at first, and then you get a bigger blast radius as you start getting good at this. But you don't start with Kong. you vary real-world events. So when you're prodding the system, you're not just coming up with flights of fantasy. It can be tempting, I admit, to sit there and go, what happens if every service dies in a strange cascade that I've just made up? The problem with that experiment is that the point of an experiment isn't to harm the system in a fascinating way. In fact, if you want to be a chaos engineer, there's one personality trait that you absolutely must have in spades: empathy. You're going to be in a position where you can destroy people's stuff. You shouldn't be doing that to surprise them, and you shouldn't be doing that because you can. Okay? But also, you shouldn't be coming up with crazy stuff, because an experiment's purpose is for people to learn. And if you say to them, if I do this crazy experiment, your stuff doesn't handle it, the response might be, of course it doesn't. It'll never handle that. That never happens. Fair point. Unless it has happened, you really have no leg to stand on. What you want to do is find something that has happened and vary it a little bit. The best way to start chaos engineering is to get everyone together and go, when was the last time production failed? And how? And then what you do is you start to go, well, are we any better now? If that happens again, can it happen again? And you start to explore what you might need to do to deal with that real-world situation. And you cause the real-world events against your system. This is controversial. The best place to run chaos experiments is in the real world that is production. It's where you will learn the real lessons. The problem with lessons that you learn from staging are they are only applicable to staging. Or at least anyone who is told, if you do this in staging, bad things happen, people will turn around and go, yeah, but that'll never happen in production. Even if it has in the past, it can't ever happen again, someone's coped with this. So what you're looking to do always is to give it the biggest leverage to the lesson. We're going to go to the effort of trying to harm the system in an interesting but real way, and we want that lesson learned once we've done it. And then we automate these things, because they're not one-offs. You could run a chaos experiment today where you destroy microservice X, and everything's fine. You do it tomorrow, when you've just launched Game of Thrones, that service X might have a problem, and the whole thing could go cascadingly down. So it's important to continuously run it. Now, there is a cadence to these things. Chaos Kong, as I say, pretends that the apocalypse has happened. That is not run continuously, because it will affect you. It will affect customers. So you run it, but you run it in a very careful way at a certain period of time, not when you've just launched House of Cards or something else that people like to watch. So run continuously, like continuous delivery. It's not about necessarily running it all the time. It's about being able to run it whenever you'd like to, within the bounds of the impact that you expect to happen. And now I can show you how to get started with this. Because a while ago, it was actually quite tricky to get started. The tools themselves were often quite specific. You know, you're probably not, anyone here from Netflix? Because I'm about to say you're probably not Netflix, but if you are, great. But you're probably not. So a lot of the tooling they have, great as it is, open source as it is, isn't necessarily tuned to what you might be worried about. So what my friend and I did, and a few others in the community, is we created this little toolkit that would help us do chaos for anyone who was trying to approach the topic. I'm going to show you a little bit of it now. Okay, boom. So these things are available and free online as well. If you want to see the Chaos Toolkit, that's one way, but let's look at GitHub. All the cool stuff's there. Boom, boom, boom. This is it. Made up a bunch of, I should warn you, it's written in Python. I am proud of that. I should also point out that I'm not the best Python programmer. My best friend Sylvain is. He is French. It is Python. It was his rule. Okay. So we've written these little tutorials to help you get started. The main thing to point out is that it's really simple to use. We have three main steps to it. You can install it, obviously. You can run your first chaos experiment. We'll look at that in a minute. And then you can discover and initialize your experiments. The cool thing about running a chaos experiment is it kind of demonstrates what I'm going to talk about, or what I'm going to show you now. Okay, so the first thing is there's a chaos run command. So we do our Python thing. We've activated our virtual environment. We can now go ahead, run it. No, we can't because it's still catching up. There it is. It's there. We now have a chaos. I'm sorry if it's small at the back. I don't know if I can zoom in. No, zooming on this is a terrible idea. Oh, look at that. I can. Can you see it at the back now? Vaguely? Cool. Right. So chaos has a chaos one. It's just a CLI. Now I can't get over to the left. Sorry. After teasing you with it, I now need to zoom around. Here we go. So first thing we need is something to test. Now, I'm not going to create a big, complicated system here, because creating 10,000 microservices and running up in Kubernetes would probably take longer than the weekend, or certainly longer than I've got remaining on the talk. So instead, what I'm going to do is create a highly complicated one-service Python file and run that up instead. So it's just a Python file. If you don't know Python, don't worry. It's just going to put a little web server on port 8080 and respond with something half intelligent. I could run it, but it's probably best to go ahead and think about the experiment now. Now, in Chaos Toolkit, at least, an experiment is described. You write it descriptively. You don't have to get down into the meat of the code. You can write it using JSON. I apologize if JSON is not your flavor. If you'd like it to be written in YAML, please get involved in the project and write it in YAML. I personally have wasted too many days of my life on YAML. So I tend to avoid it. But we've got JSON for now, but it's certainly not the only thing you could have. Main thing to point out in this is we've got a description for our experiment. It's going to, does our system tolerate the loss of its exchange file? Pretty simple. There's a little file that this service is probably assuming should be there, but it's possible it could go away. So we're going to see what happens. We now add our steady state hypothesis, which if you can't see from the back, it's very simply saying the exchange file must exist. Now, point something out about steady state hypotheses. They're used twice. This is a major difference between running chaos experiments and what I understand are most testing techniques. The closest testing technique to chaos engineering is probably exploratory testing, where you don't really know what's going to happen. That's the closest I can think of. We use this steady state hypothesis. And what that says is when I look at the system, in this case we're just going to look at a particular URL, we believe we're going to see one of a few set of return status codes, even when we've changed the system conditions, which is what the rest of the experiment will do. And I mentioned it was used twice. It's used at the beginning of the experiment. There's no point doing a chaos experiment against a system that you don't recognize. So the steady state hypothesis is also used as the gate. It says, okay, things look like they should be. In fact, the steady state hypothesis can be thought of as this defines what normality looks like. So we start an experiment if the steady state hypothesis passes. What we can do then is add in our method. And I won't walk through it all with it for everyone, but all it's doing is taking a file out. Now, there are schools of thought on this. Some systems attempt to have automatic rollback for your changes. This system doesn't. The reason it doesn't is automatic rollback only makes sense at the infrastructure level. It very rarely makes sense at the application level. So most experiments that I end up writing tend to hit all those different levels. And when you do that, you realize that rollback automatically is impossible because the system has become potentially quite corrupted at that point. Now, you can put a block in there to say, here are the rollbacks that I would like you to do, but it's not automatic. And what we're going to do is we're going to run this method, and then what happens is we then take that steady state hypothesis and go, does our system still look within the tolerance of normality? Okay, I'm not going to run it for you here, but you can run it for yourselves online. This is all available for free. But what you will see when you do run through this tutorial, is that when you run it the first time, the piece of Python code has been written naively to assume that exchange file is there. And it does not respond well within these tolerances when the file isn't. Then what you do is you improve the system. So we then improve the Python code so we now don't assume that file is always there because it might not be there. And then we run the chaos experiment again, and you can see that the service still stays within its tolerance even when this dependency has varied. Now, it's a trivial example, but hopefully it's illustrative of what you can start to do. This is the thought process, which is what can we do to the system, and what does normality look like, and we'll try to stay within those bounds. And if we deviate, that's when we go and look at our system and go, what happened here? That actually is something that's an important message. There is a low bar, a rule, if you like, to doing chaos engineering. You can't do chaos engineering if you don't have good observability of the system already. I don't know if you go to many theme parks, but you know when you go to a theme park and there's a bar there and it says you have to be this high to get on the ride. I'm always worried by that. Being a short person, one day I'm going to be walking in there with my daughter and she'll be taller than me. And she'll get on and I won't. But that bar for chaos engineering is observability. So you will invest in observability first. Because the one thing you want to do is when you do a chaos experiment, you want to be able to go look at the system and go, what happened? Okay? The chaos experiment can tell you where we deviated from the steady state hypothesis, but it can't tell you why. So that's why you need the observability as well. Okay, so that's a little bit on the Chaos Toolkit, and if you want to go and start using it, like I say, it's free, open source, please do. We're always looking for people to play with it and to let us know how it went. Right now, I'm going to go get back to the slides. Okay, so there are some rules of Chaos Club. If you're interested in doing this technique, then there are some rules to live by. And I want to make sure that these sink in. Number one, we're doing it to learn about the system. We're trying to figure out where the weaknesses might be in our whole socio-technical system when it comes to these extreme conditions that the system can come under. And then we're looking to improve on that. So it's not really about breaking stuff. This is for me, the major misunderstanding of Chaos Monkey, is that when you do look at it and it says, I break stuff for a living, you do sit there and go, why? That can't be good. The thing about chaos engineering is hopefully it lifts the awareness a little bit higher and says it's about learning from that harm. In fact, it's not even necessarily harm. It's learning from real-world conditions and small variations. Rule number two, chaos is not a surprise. Can't hammer this home enough. If you decide to become a chaos engineer in whatever capacity, and the first thing you do is destroy some stuff in production, and it surprises everyone involved, you lose. No one is going to be happy with that. Chaos starts with a conversation. What you do is you go and speak to the teams that look after that software, whether they be DevOps or whatever. So you go and talk to them and say, what worries you about your stuff? Is there anything in there that you think might be a little fragile? Do you want us to see if it's fragile? And then do you want us to figure out how we improve it? So it's a big dialogue. And what we have in the whole chaos automation and chaos toolkit is if you like, just some tooling to support that dialogue around how we improve the system. So it's about learning, not harm. And it shouldn't be a surprise to anybody because you've already spoken to them about it. In fact, this is actual true anecdote when it happened to me recently. Just telling people that chaos is coming can lead to awesome improvements. I said to us, there's a system running over in the States, a lovely group of people around it, but they were, like all developers, they didn't want to use circuit breakers because they couldn't see the point. They're always going to be there, it's fine. And so I said, okay, in about 2 months' time, I'm going to run a limited version of Chaos, Kubernetes Chaos Monkey against your system. And okay, why? I said, you said it'd be fine. It happens, pods die. So I'm going to make it happen a little bit, okay? Yeah, great. They worked so hard for those few months before the Chaos Cube turned up. And I was very proud of it as well, because when I did put it on the system, they said, it does survive, it's great. I was like, fantastic, you've improved the system beautifully. And then, of course, as a chaos engineer, you say, what else makes you nervous? And then we'll try and do that too. Rule number 3, I mentioned this before. You don't do chaos if you already know. If you already know the system's going to collapse in flames, then it's not an experiment, it's just sadism. So don't do it. And it goes hand in hand with this idea of being a very empathetic individual if you're a chaos engineer, and that dialogue you're supposed to be having. If you have a dialogue and they say, whoa, please don't do that, it'll kill it, your next step shouldn't be to do it. So this is all part of the chaos world, is we're interested in learning, and if we already know the answer, we're not learning anything, so it's not really our game. So when it comes to chaos engineering, the thing I want to leave you with today, apart from the toolkit that I hope you go and play with, is the book itself. If you haven't got it, get it. I should point something out about this industry. I've been around long enough in this industry to watch us do a lot of things cargo cult. I used to be a consultant for being like a consultant agile person, right? I used to get phone calls where someone would say, we've just done this agile transformation thing for a couple of years. Spent a lot of money. Could you come in as an expert and tell us why it's better? What? Didn't you know what you were trying to improve? No. We knew we had to be agile. We've done that. Now we're not sure why. And someone at the top is asking awkward questions about it. So can you come in and convince them that we're a lot better now than we used to be? And there are lots of other things in our industry that we do that with. Even microservices, which I'm relatively moderately famous for talking about a lot and building a lot of. You can do microservices where you create all of the problems of a monolith, and you do it in a distributed system that you can't manage. And so in the terms of microservices, if you just do microservices because someone else has done them, you'll get them wrong. Recently, I was on a phone call with a client, and they don't mind me mentioning this to you. They said to me, they started with a question. They said, how do you deploy 40 microservices at once? You don't. Ever. One at a time. You should always be able to deliver one at a time. If you have to do 2 or 3, you've got the wrong microservices. And so I had a long conversation with them about that. And that's because we tend to, in this industry, cargo cult new things. So when it comes to chaos engineering, I feel very privileged that the people that came up with it, even though the name's interestingly bad, it's cool enough, though. You can be now a director of chaos, which is not a bad thing. We actually have a technique that I think is hard to get wrong. As long as you understand that you're not just hurting stuff and people, then it really is a genuine way of improving systems. And it's nice, actually, to be able to say, in a world where we don't have a lot of best practices or even good practices, this is one of the few things where I can say, just do it. Get into it now, because you're going to see value even if you just do a game day. Even if you just get 4 or 5 of your friends together and go, what happens if the system dies? How are we going to deal with this? I'll give you a last story. I was talking to a great friend of mine, Alexis Richardson, and he was delivering a talk that day. And the talk was about how quickly they could reproduce their system, which is Weave. And the story he tells is he's sitting there in the office with one of his developers, and the developer turns around and says, I've found a big red button. If I press it, production gets wiped out. Gone from the history books. And Alexis tells us, the next moment, Alexis is just turning around when he hears click. Because if you see a button, you're going to press it, right? This is why we have a big red button on Donald Trump's desk that is not attached to anything. Okay, we are slightly advanced monkeys or apes or whatever. We will press a button. What Alexis then found out was that they could recreate the whole of their system in 45 minutes, which is pretty damn good under that level of stress. But if you're a chaos engineer, right, so Alexis's response to this was, then we're going to get rid of that button. As a chaos engineer, your mindset should be, can we press that button more often? We'll improve. We'll get that 45 minutes down pretty damn quickly if we press it once a day. Do you see what I mean? Harm the system in intelligent ways, because it can happen, but these buttons exist. and then you can see how the system improves on the back of it. Okay, so go grab the book. Please have a look at the Chaos Toolkit. That's who I am, so if you want to get in touch, please do. Otherwise, thank you so much for hanging in there to the end of the conference. You are the diehards, or, like me, you do not have a life. One of the two. But thank you very much for being patient and hanging in there till the end, and I'm open for questions. I do warn you I have to run and go and get my daughter, but other than that, I will happily answer your questions, or I'll give you business cards and we'll start a dialogue, not through email. Email's a terrible idea. We'll start a dialogue through LinkedIn or something. Thank you very much. Cheers.